So whatever we are assuming that ideal channel, everything is fine, no errors. So simple algorithm will serve the purpose. But now, practically speaking, so no ideal channels are available. Every channel will have some disturbance, some noise, some interference will be there in every communication path. So if we consider that point, then based on the noisy channel, by considering the disturbances in the communication path, we will think that we will say the channel is noisy channel. If it is a noisy channel, then whatever existing algorithms we have already come across in last two different cases, simplest and simplest with stop and wait, it need to be the simplest with stop and wait need to be modified. Okay, based on that, three more methods are being derived. So we are coming across three more different methods which are suitable for noisy channel. So what it is: stop and wait automatic repeat request, go back and automatic repeat request. Third one is selective repeat automatic repeat request. Here the automatic repeat request means if there is any error, then automatically retransmission request will go as a negative acknowledgement. So that is why the automatic repeat request is the name included with this. Stop and wait with automatic repeat request. Go back and with automatic repeat request. Selective repeat with automatic repeat request. So in all these three cases, suitable for the noisy channel, and whenever any error is detected, that means now the sender will, in these cases, the sending data link layer while preparing the frame. So header part will have the size of the frame and the physical address of the sender and physical address of the receiver plus the trailer part. So it is going to compute the checksum. Then that checksum will be included in the trailer part. So that same procedure or same mechanism will be used by the destination data link layer to verify whether received information is having any errors or not. So the received information should not have any errors. So it has to able to identify. If at all any errors are there, the receiver should able to detect that there are some errors. So for that, the error checking mechanism is included at the data link layer of sender. So that is done in these methods. Then in the receiver's data link layer, it is going to verify using the same checksum method. It will verify whether received information is having any errors or not. If no errors, received information will be handed over to the network layer and a positive acknowledgement to the sender, so that sender will send the next one. If received information is having any errors, then the received data link layer will discard the information received at the data link layer itself. It is going to be discarded at the data link layer itself, will not be handed over to the network layer for further processing, because anyway it is having errors. Why it is to be processed? So it will be discarded at the data link layer and it is going to ask for the retransmission. Whatever is received, not received correctly, please send me again. That is the meaning of the feedback coming from the receiver to the sender. So what are these basically, how these three are different? In case of stop and wait, so sender will send one frame and waiting for the confirmation. After getting the confirmation, the next part will be transmitted. If confirmation says received is correct, then the sender will send the next one. If the confirmation says received is not correct, then sender will send the same again. So that is an automatic, that stop and wait with automatic repeat request. So it will send one frame, wait for the acknowledgement. Based on the acknowledgement, either if acknowledgement is negative, same frame is transmitted again. If the acknowledgement is positive, next frame is transmitted. That is the procedure used in stop and wait automatic repeat request. We'll see detailedly in the next few slides. The second one is go back and automatic repeat request. So in the first method, what is happening? A lot of time is being wasted for the sender and receiver, because so sender will send the information frame and wait for the confirmation. So it takes time because the information has to reach the destination. Destination has to verify for errors. Then destination will send the feedback. The feedback has to arrive the source, that is the sender. Then based on the feedback, next step. So the ideal time of sender is more. So after sending a frame, should sit idle. The sender should sit idle. So a lot of time is being wasted. So to reduce that wastage of time, the second method, go back and, is being derived. So in this go back and, now the sender will keep on sending the frame after the frame without waiting for the acknowledgement for the before sending the next. Now the in case of second method, now the sender will not wait for the confirmation. So after sending first frame, so it is going to send the second frame, then third, then fourth, likewise. The moment it receives at the receiver side, and receiver after receiving the first frame will check for errors. If no errors, so receiver will be sending the acknowledgement. Then second, that the same. Continuously they are going to do this. Suppose in this case, that is the second method case, suppose the frame number 3 is not received correctly at the receiver side. Say for example, frame number 3 is not received correctly. Then the receiver will reject all subsequent frames also from frame number 3 onwards. So it will send a negative acknowledgement for frame 3 and all other subsequent frames will be discarded. So go back and from 3 onwards, go back. I don't want. That is the meaning of this go back n. So here n is 3 for example, because third frame is not received correctly. So n is 3, go back 3. So from third onwards will be rejected because frame 0, frame 1, frame 2 received correctly. They are being processed and hand over to the network layer, and frame 3 has arrived wrongly. So first I have to hand over the frame 3 to the network layer, only then I can hand over the 4. So I don't want to accept any, okay, out of order. So then it is going to reject from faulty frame onwards, even though the subsequent frames are arrived correctly also. So the receiver is not bothered about it, simply it is going to reject. This is what is happening in this. Compared to the first method, little faster, though the moment it encounter any error frame, so from there onwards all of them will be rejected. Now the sender has to send again from error frame onwards again. So likewise, but again it can keep on sending without waiting for the acknowledgement. So as a result, compared to the first method, and the second method is faster. So that is the second one. So here also the disadvantage is unnecessarily the receiver is rejecting the good frames also. Once the receiver detects that a particular frame is faulty, all subsequent frames of that frame will be rejected even though they might be received correctly. So unnecessarily those frames also need to be retransmitted by the sender unnecessarily. So this is a problem in the second method. So that is why a modification of this is third, selective repeat. Selective repeat. So in selective repeat, here also keep on sending. Sender will be keep on sending and receiver is keep on receiving the frames. So the moment receiver receives, it is going to verify for errors. If no errors, there we keep on handing over to the network layer. The moment a particular frame is having error, so it will send a negative acknowledgement for that, and subsequent frames will not be rejected. Now the receiver is not going to reject the subsequent frames. Suppose frame number 5 is having error. So frame 0 to 4 are received correctly. Frame 5 is received with errors. Then, so the receiver will verify, and if frame 5 is having error, so it is going to send the negative acknowledgement for frame 5. Then frame 6, if it is okay, frame 6 it is going to verify and store in the buffer. Data link layer buffer will store the subsequent frames. They are not being handed out to the network layer, but they will be stored in the buffers of data link layer. The moment the sender gets this negative acknowledgement for the frame 5, the sender will retransmit only frame 5, only frame 5. Then suppose while the sender is receiving the negative acknowledgement for frame 5, already sender has transmitted frame 12 also, for example. Now after 12, before sending 13, so the sender will send frame 5 again. Then, so already 12 is transmitted. So after 5, again it is going to continue from 13 onwards. Sender will continue from 13 onwards. So after 5, 6, 7, so on will not be repeated. So that is selective repeat. So whichever frame is error, only that particular frame will be retransmitted. All others will be accepted as it is. So that is the meaning of selective repeat. As a result, only the faulty frame need to be retransmitted. But in case of second one, faulty frame onwards will be retransmitted. The second case, faulty frame onwards will be retransmitted again. In third case, only the faulty frame will be retransmitted. So the moment it receives the faulty frame replacement, if it is okay now, then till then whatever are received, all of them will be handed over to the network layer. Without whatever is received without errors, all of them will be handed over to the network layer. So highest frame number will be sent as acknowledgement at that moment to the sender. That means up to that frame all are okay. Suppose by the time 5 is received, already up to 12 has received, again 5 is received second time. If 5 is okay, then receiver will send the acknowledgement, positive acknowledgement for 12. That means now 5 is also okay. Up to 12 are okay. That is how the selective repeat case is being used. Anyway, we are going to discuss all these detailedly